Hello there. This is the second of two videos on section 5.4. In this video, I'm going to be going over how to interpret the meaning of a definite integral in the context of a word problem. So we'll do a few examples, but they all have the same flavor in that the definite integral measures the net gain in a quantity, whatever over that interval, whatever the interval is being measured in. So let's see a few examples. We'll start off with the classic example of velocity. So the output variable is velocity, which is measured in feet per second. And the input variable is time, measured in seconds. And when we're finding the definite integral, what we're doing is we are looking at a curve. This is the square root x curve that we're going to be doing, or square root t curve. And we're going to be looking at the area between the graph and the x-axis between the given input values. So in this particular expression right here, we're going to calculate and explain the meaning of this area between t equals 4 and t equals 9. And if you remember from previous episodes, from previous videos, we can easily determine the units because we are multiplying feet per second, the vertical direction, times seconds, the horizontal direction. And feet per second times seconds is going to equal feet. All right, so let's go ahead and calculate this. So this integral goes from t equals 4 up to t equals 9 of the square root of t dt function. We actually differentiated this in the previous video. I wrote this as t to the 1/2 exponent and then used one of the formulas for anti-differentiating, getting t to the 3/2 times 2/3. And we evaluated this from t equals 4 to t equals 9. And that gave 38 thirds as the area. Now this area is measured in feet. You can see this because the square root of t is the y, and y, or v, is measured in feet per second. And dt is the t, which is measured in seconds. And as I just showed, feet per second times seconds is equal to feet. So that's the value of the definite integral. What does that really mean in this particular context? Well, each of these numbers should have some units. For example, the 38 or 30, I think it's 39 over 2, whatever the number is here, that is going to be the number of feet. And then all the other numbers are going to be also with the units. So t equals 4 is 4 seconds. T equals 9 is 9 seconds. So we have something going on between t equals 4 seconds and t equals 9 seconds. So between 4 seconds and 9 seconds, we have something being a total of 38 over, this is 30 over 3, I double checked, 38 over 3 feet. So we would say between 4 seconds and 9 seconds, what happened between these times? Well, this object, the object traveled, and this is the distance because the feet per second is the velocity. So when I multiply, I get feet. So I get distance, that's the quantity, feet. So traveled a net distance of 38 over 3 feet. So the distance traveled, now, of course, this is all positive. So you could just say in this case, the total distance because there's no negatives, right? There's no negative area or negative distances. So in this case, since all the distances are positive, you can say the object traveled a total distance of 38 over 3 feet. In general, it could be a net distance because some of the distances could be backwards, could be negative distance if it goes below the x-axis. So that's what we're going to be doing a few times today, is trying to evaluate a definite integral, get a value, and explain what that value means. And this sentence structure, between this time interval, we have a quantity, a net total quantity of whatever the integral is equal to. That will reappear in pretty much all the answers. Well, I did want to contrast this definite integral with an indefinite integral. So before we do some more definite integral problems, I wanted to quickly do a indefinite integral. So there's no numbers on the integral sign. This is just the integral of square root t dt. And this integral of square root t dt is no longer an area. It is an antiderivative. So if I do this, by the way, it's the same calculation we did before. It's the integral of t to the 1/2 dt, which is equal to 2/3 t to the 3/2 plus c. Well, I guess I should have added my plus c up here. I did in the previous video, and then the c and the minus c added to 0. So I kind of got in the habit of ignoring the c, but there is a plus c. It just doesn't matter when we're doing definite integrals because they always equal 0. But in an indefinite integral, you definitely have to have the plus c there. So what is this thing? Well, this is a function. More specifically, it's the antiderivative function. So what do we have here? We have this function. So this function here, I'll just call it capital FT, 2/3 t to the 3/2 plus c is the function, and I'm going to leave a little space there, whose derivative equals square root of t. So that's basically all we're saying. It's the antiderivative. So this is the thing that when I differentiate it, I get the original function, which is square root of t. The reason why I left a little blank here is because we actually call this a family of functions. Family of functions. The reason why I call it a family of functions is because plus c could be +1 or +7 or -2 or anything, right? So it's not one particular function. It's a function type plus c. So in math vocabulary, they call this a family of functions. So that's what this integral of square root t dt is equal to. It's an antiderivative function. And of course, we can solve for the c if we're given certain information. Here we're told that the distance is 100 feet. Oh, by the way, if my original function v of t is equal to square root of t, and I'm anti-differentiating this v of t, and I'm anti-differentiating this square root of t, the antiderivative of velocity is distance, right? So this function here is really the distance function. So just to reiterate that idea. So here it says we have a distance of 100 at time 0. So we have our function here, which is our distance function. I do know that at time 0, this is t equals 0, the distance is 100. The distance is not the v equation. It's not the original equation we're given. It's the function this. So f of 0 is equal to 100. So I can put 100 in here as long as I substitute the value of t as 0. And I can solve for c. This is all 0 here. So we get c, well, officially we get 0 plus c is equal to 100, but that just means that c is equal to 100. So we know that c is equal to 100 And that way we can write not a family of functions, we can write the very specific function. So our function is equal to 2/3 t to the 3/2 plus c. And we are told now at time 0, we have a distance of 100. So this function will calculate the additional distance, the net distance beyond 100, right? How much extra distance we get. So if we had f of 3, that would be the additional net distance from 0 to 3 seconds. Oh, I put the plus c there, and I don't think I said plus c, but I see it now. I don't know what happened. That should be plus 100 because we just found out c was 100. So we're supposed to put it in there. I didn't for some reason, but I did catch my mistake. So that is the specific function given the fact that the time 0 distance is 100. All right, so hopefully I explained that well enough. We're going to do a couple more examples of definite integrals. I just wanted to contrast it with an indefinite integral just once, just so that that sort of similarity and differences are still sort of present in your mind. All right, so this is my other page. I have a couple of examples here, and then this will be the end of the video for today. Zoom in a bit. All right, so example K here, I have a function called MPX, and it's this quadratic 3x squared minus 2x plus 1. And what does it measure? It measures the rate of profit. So that's the vertical axis. This is the rate of profit in dollars per item sold. And then the horizontal axis will be items. So then when I multiply dollars per item times items, I get dollars, right? In this case, we have a parabola function. I don't know exactly what it looks like. We'll just pretend it looks something like this. So between 2 and 5, so between 2 and 5, we have a particular area, and we're interpreting that area as the amount of money. All right, well, let's go ahead and find the value so we can include that in our sentence. So we have the antiderivative, the integral actually, from x equals 2 to x equals 5 of the MP function, which is 3x squared minus 2x plus 1. And we do have that dx thing, which will have more importance, as you will see in section 5.5. Don't forget it. It is important for many reasons. It doesn't necessarily seem that important right now, but you just have to take my word for it. It will play many uses, so please don't neglect writing the dx. All right, I don't really write the parentheses. It's really this thing, this y thing, times this x thing. So I get dollars per item times items, but it just ends up being messy and harder to explain when I put the parentheses. So hopefully you'll indulge me and not still understand what I'm doing when there's no parentheses there. So I'm going to use the fundamental theorem of calculus. I'm going to antidifferentiate this thing. The antiderivative of 3x squared is 3x cubed over 3, or just x cubed. And the antiderivative of minus 2x is minus 2x squared over 2, or just minus x squared. The antiderivative of 1 is just x, and we do get a constant of integration. And we're going to evaluate this thing from 2 to 5. Okay, so when I plug in the top number, I plug in 5. Oh, I'm just going to simplify this, I guess. This is going to be x cubed minus x squared plus x plus c from 2 to 5. All right, so let's just do the calculations. If I plug in the 5, if I plug in the 5 into my formula, I get 5 cubed minus 5 squared plus 5 plus c minus when I plug in the bottom. So the bottom is going to be plugging in x equals 2. 2 cubed is 8. 2 squared is 4. 2 is 2. And c is c. And that is the, antiderivative evaluated at the two endpoints. and subtracted, as we know the fundamental theorem of calculus allows us to calculate the definite integral. All right, well, 125 minus 25 plus 5, that's going to be 105 plus c. So 105 plus c. We have 8 minus 4 plus 2. That's going to be 6 minus c, because remember the minus goes to everything. So I guess it's minus 8 plus 4 minus 2, which gives minus 6, or I can just do what's inside the parentheses first. 8 minus 4 is 4 plus 2 is 6, so it's minus 6 minus c. The plus c and the minus c will always add to 0, and I get a grand total of 99. 105 minus 6 is 99. 99 what's? What did I just get? 99 apples, 99 feet, 99 seconds. None of those. 99 is the area, right? That's the integral we just calculated. And the area is the vertical times the horizontal. It's dollars per item times items. So this is measured in dollars. $99 is the area. Kind of funny to say area is dollars, but that's what the units say when I have multiplying a rate, dollars per item times the number of items. Then I get the quantity of dollars. Okay, so what did I have? Well, I know that the original function was marginal profit, so the antiderivative function is going to be profit. So between what we got? So we got 2 and 5. Between 2 items sold and 5 items sold, the net profit was $99. So that's the total amount of profit that we gained or subtracted between selling 2 items and 5 items. And that's another example of how to interpret the meaning of a definite integral in the context. All right, we'll do one more, and then that'll be it for this video. Last video, the rate income measured in thousands of dollars per year for a company is given by that equation, where X is the number of years since 2010, and we're supposed to find the meaning of this definite integral. If you haven't paused the video, this is a good time to try it. Perhaps you will be integrating something that needs to be simplified, so you can think about that. Give it a try if you wish, and then come on back and I'll show you my solution. All right, well, hopefully welcome back. I'll just remind you that the vertical axis is the rate, and that's measured in dollars per year. And the horizontal axis is number of years since 2010, but it's the years nonetheless. S-I-N-C-E, since 2010. So my area is going to be the vertical direction, dollars per year, times the horizontal direction, which is years, and that's going to be an area measured in dollars. Dollars per year times years is equal to dollars. All right, so we're going to find this antiderivative, specifically the integral from x equals 3 to x equals 5 of this function 6 x plus 2 over x dx. All right, so we're going to want to antidifferentiate this and evaluate it at the endpoints. This is not easy to antidifferentiate without simplifying first, and we have some choices on how to simplify this. In this particular case, I would recommend trying to distribute as much as possible so that we can separate things with plus signs and minus signs, because each individual function separated by a plus sign or a minus sign, we can integrate separately. It's not true with multiplication or division, but definitely with addition and subtraction, we have that sum difference rule for differentiation as well as for antidifferentiation. All right, well, x plus 2 times x plus 4. I'll do a little side work over here. We'll do this as a demo. We can do some side work. So, this is a way of communicating your solution process. So this function here, I'm going to multiply out the two binomials. I get x squared plus 4x plus 2x plus 8. And that's supposed to be an x in the bottom. And then I'll distribute the 6, and that'll be 6x squared plus 36x plus 48. And then I'm dividing everything by x. So you know what I can do is I can just divide each thing by x. That's, again, the distributive property. So divide each term by x. And that gives 6x plus 36 plus 48 over x. And so over here, I can go back to my problem. I have 3 and 5, yeah. And this expression right here, we just did some side work. This is an x over here. It's going to be 6x plus 36. My pen's working over here. That's a 36. And then plus 48 over x. And that's a dx. And each of these are known integration formulas. So the antiderivative of 6x is going to be 6x squared over 2. 6x squared over 2, I can just write as 3x squared, because the 6 and 2 are going to simplify. So I'll write this as 3x squared. And then the derivative of 3x squared is 6x, so you can verify that. The antiderivative of 36 is 36x. And the antiderivative of 48 over x, the 48 is a constant multiple. So just like the other constant multiples, it doesn't do anything. And the antiderivative of 1 over x is ln of x. We get a plus c. We do have to evaluate this at the endpoints. So we're going to have to put in the values of x equals 3 and x equals 5. So we get, when I plug in 5, I get 3 times 5 squared. 3 times 5 squared, I'll just write it out, 3 times 5 squared, plus 36 times 5, plus 48 times the natural log of 5, plus RC. And then we're going to subtract when I plug in 3. So very similar kind of calculation, but I'm going to be substituting the value 3 instead of the value of 5. In this case, it's 48 ln of 3, and then plus c. You probably will notice again that we have a plus c and we have a minus c, and those are going to subtract off or cancel out, as a lot of people say. I'm going to pause the video just for a moment, pop over to Desmos, and just throw these numbers in here just to save a little bit of time on the video to get an actual number for this. All right, so hopefully you double check my calculations, but when I put all these numbers into Desmos, it gave me about 144.52 after I rounded it to 3 decimal places, so 520 if you like. And what is the units for that? Well, remember, we had dollars per year times year, so this is dollars. And I'm ready for my interpretation sentence. Again, this is years since 2010. So x equals 3 is 3 years since 2010, aka 2013, and x equals 5 would be 2015. So my between in this case is between the years of 2013 and 2015. So I would say between 2013 and 2015. And what's the context? What are we measuring on this problem? The rate of income. So the quantity is income. So the income of a company, so the net income would be the antiderivative. The net income of the company was $144 and 52 cents. Not a lot of money unless that was measured in millions, but it doesn't say it's measured in anything like that. So, oh, it's measured in thousands of dollars. Oh, I forgot about that. Good thing I double checked. So the vertical axis is not dollars per year. The vertical axis is thousands of dollars per year. And if I take thousands of dollars per year and multiply by years, I get thousands of dollars. Okay, it didn't seem like a lot of money, but that's because I forgot that it's in thousands of dollars. So somehow I missed that when reading the directions. So this would be 144.2 thousand dollars. So we can write this in a normal way. $144.52 thousand dollars is not a typical way to write it. We would write it with 144 comma 520. That's $144,522 dollars. So my answer is between the years of 2013 and 2005, the net income of the company was $144,520. Okay, that's it for today's video on explaining the meaning of definite integrals in the context of a word problem. Please reach out if you have any questions, and I hope you have an enjoyable day.